Good morning, my dear students. Our today's topic is organization of data. In the previous chapter, you have learned about how data is collected. You also came to know the difference between census and sampling. In this chapter, you will know how the data that you collected are to be classified. The purpose of classifying raw data is to bring order in them so that they can be subjected to further statistical analysis easily. Have you ever observed your local junk dealer or kabdiwala to whom you sell old newspapers, broken household items, empty glass bottles, etc.? He purchases these things from you and sells them to those who recycle them. But with so much junk in his shop, it would be very difficult for him to manage his trade if he had not organized them properly. To ease his situation, he suitably groups or classifies various junk. He puts old newspapers together and ties them with a rope. Then collects all empty glass bottles in a sack. He heaps the articles of metals in one corner of his shop. In this way, he groups his junk into different classes, newspapers, plastics, glass, metals, etc., and bring order in them. Once his junk is arranged and classified, it becomes easier for him to find a particular item that a buyer may demand. Classification, therefore, is arranging or organizing things into groups or classes based on some criteria. It is a systematic grouping of units according to their common characteristics. Types of classification. The groups or classes of a classification is done in various ways. Instead of classifying your books according to subjects, history, geography, mathematics, etc., you could have classified them otherwise in an alphabetical order, or you could have also classified them according to year of publication. The way you want to classify them would depend on your requirement. Qualitative, quantitative, chronological, and geographical are the important types of classification. Chronological classification. The raw data is classified in various ways depending on the purpose. They can be grouped according to time. Such a classification is known as chronological classification. In such a classification, data are classified as either in ascending or in descending order with reference to time. Such as years, quarters, months, weeks, etc. Population of India from 1941 to 1991 is arranged in chronological order. It is an example of chronological classification. Spatial classification. In spatial classification, the data classified with reference to geographical location such as countries, states, cities, districts, etc. This classification is also known as geographical classification. State-wise estimate of production of food grains is an example of geographical or spatial classification. Qualitative classification. Sometimes characteristics of data cannot be expressed quantitatively. Such characteristics are called qualities or attributes. For example, nationality, literacy, religion, gender, etc. They cannot be measured, yet these attributes can be classified on the basis of whether the presence or absence of qualitative characteristics. Such a classification of data on attributes is called qualitative classification. Classification of data according to qualitative characteristics such as sex, honesty, intelligence, literacy, color, religion, marital status, etc. Quantitative classification. Characteristics like height, weight, age, marks of students, etc. are quantitative in nature. When the collected data of such characteristics are grouped into classes, it becomes a quantitative classification. Weights of students is an example of quantitative classification. Variables. Variables differ on the basis of specific criterion. They are broadly classified into two types, continuous and discrete. Continuous variable. A continuous variable can take any numerical value. It may take integral values like 1, 2, 3, 4, etc. Fractional values like 1 by 2, 2 by 3, etc. and values that are not exact fractions like root 2 is equal to 1.414, root 3 is equal to 1.732, etc. For example, the height of a student as he or she grows say from 90 centimeter to 150 centimeter. It would take all the values in between them. It can take values that are all numbers like 90 centimeter, 100 centimeter, 108 centimeter. It can also take fractional values like 90.85 centimeter, 102.34 centimeter, etc. that are not whole numbers. Thus, the variable height is capable of manifesting in every conceivable value, and its values can also be broken down into infinite gradations. Other examples of a continuous variable are weight, time, distance, etc. Discrete variable. Unlike a continuous variable, a discrete variable can take only certain values. Its value changes only by finite jumps. It jumps from one value to another, but does not take any intermediate value between them. For example, a variable like number of students in a class for different classes would assume values that are only whole numbers. It cannot take any fractional value like 0.5 because half of a student is observed. Therefore, it cannot take a value like 25.5 between 25 and 26. Instead, its value could have been either 25 or 26. What we observe is that as its value changes from 25 to 26, the values in between them, the fractions, are not taken by it. Thank you.